Our next speaker works at the London South Bank University. Her official department is the Explosion and Fire Research Group. There's nothing else I can really say apart from to welcome to the stage, please, round of applause for Dr. Claire Benson.
Good afternoon. I'm Claire Benson from the Explosion and Fire Research Group, and I'm a fire and explosion scientist. My background education is actually in forensics, and I've got a PhD in chemical engineering, but the thing that holds all of that together is fire. It can be both spectacularly beautiful and horrifyingly destructive, sometimes at the same time. Now, my main research area is in aviation and industrial fire safety, which means that actually I'm not involved in anything Grenfell. So a lot of the real fire experts who deal with building fire safety all the time, they're involved in this process, and so they can't really come out here and do things like this so easily. But that's why I quite like to do it, so that I try and give people a bit more advice and information. The day that Grenfell happened, I awoke to the same images as everyone else. But I think my reaction was probably a little bit different to everybody else because I was only angry. There is enough knowledge and expertise in the UK alone that something like that should never, ever happen. I've taught building fire safety assessment, and my big takeaway from that was actually how difficult and complex that is. So I'm going to talk to you today about safety in tall buildings, particularly in relation to what I do, which is fire. Now, I warn you, I'm not going to be funny. My sense of humor has somewhat run out on this, and I am going to talk about some pretty terrible things like death, because, well, that's what I'm trying to stop in my industry, as are the rest of the people in it. Also, there are currently 2 investigations going on, and I don't want to jeopardize either of those, particularly a criminal investigation. You have to be quite careful what you say. So I'm going to be asking you a lot of questions and maybe presenting you with some facts and getting you to answer them instead. But hopefully I will be informative, and I'd like you, hopefully, to get 3 things out of this. 1, I want you to be able to go back to the environment where you live or where you work, and actually be able to look around you and assess what's being done in terms of fire safety for you, and maybe question if everything's being done that should be. 2, I'd like to dispel some of those myths that have built up around this subject, and there are quite a few. And 3, I want to equip you to go and talk to the people in power about this subject to see if they're doing enough to make sure that we never ever have a Grenfell again. So to that end, I'll be talking about these 4 things. What is a building meant to do in terms of fire safety? What is sometimes, in fact quite often, some buildings don't do that they're meant to do? How do we get to a place where we have a whole load of buildings doing things that actually we consider quite unsafe? And what do we do going forwards? How do we fix this mess that we've found ourselves in? Sounds really simple. But a building is meant to be safe for the people in it. And that's written into legislation. Now, around the country, around the UK, that legislation is going to vary. One of the starting points of difficulty with this is that England, Wales, Scotland, Northern Ireland all have their own rule books on this. Even though you could scientifically look at safety and work out what's safest. It will require money, but we could do that. But everybody does it differently, and that makes everything a bit confusing to start with. It wouldn't be a fire lecture without the fire triangle. But it's actually a brilliant representation of what we do in my industry. It's a huge simplification, but it is something that we use all the time. But in order to make buildings safe for people, you can't just use a simple guide. You can't just follow a set of rules. It's actually incredibly complicated. You have to understand hazards like ignition and fire spread, how to identify them, how to change them, how to switch them for something else. If you can't change those risks, how to mitigate them and put something else in to make that safe. You need to know about detection systems, or warning systems, fire suppression systems, firefighting systems, systems that are in a building to enable firefighters to do their job that you don't even know are there half the time. And also you have to understand about the evacuation, stay put, and where they may or may not be appropriate. It isn't a simple process, and the bigger the building gets, the more complex that task gets. There's a whole range of industries that are meant to be working together to make an environment safe for all of you to use. First risks to try and avoid are this: ignition. Problem is they're ruddy everywhere. If you look around this room, you will see multiple ignition sources. And if you're thinking about a building with lots and lots of what we call dwellings, homes in, you've got tons of ignition sources. There's accidental ignition, where people maybe knock over a candle. You could have natural ignition, like lightning, or even if you have glass things hanging up at your windows, sometimes if the sun's at exactly the right point, it can set fire to stuff in your house. So I would advise taking those down if you have them, really. Or you could actually have somebody wandering around an environment trying to set fire to things with arson. You've got naked flame, electrical devices, anything that produces heat, chemical reactions, a ton of stuff that could ignite. And the more dwellings you have in an environment, the more sources of heat you have, the more electrical items. So when you're designing, building, running a building, you pretty much have to do it under the assumption that although you want to minimize your ignition sources, you've got to assume a fire is going to happen at some point. So then what do you want to do? Well, you want to try and limit your spread. First way of doing that is controlling your materials. But again, if you've got a whole range of dwellings in a very tall building, even in an office, the range of materials in that environment is going to be quite wide, but particularly in dwellings where you have no control over what's in it. You can try and control what's in it, but it's very difficult with private dwellings. Recently, a council in London went around flats and they tore down everybody's sheds, very controversially. And they did it because they said, we don't know what's in the sheds. We think people might be storing varnish or paint or flammable things, and if that all ignites and then the shed ignites, that's actually a really big fire. Now, I'm not advocating what they did because there are other options, but I can understand it when you're running a building and trying to make it safe for people. It's a difficult decision to make. And even when you can control things, so what the building's made out of or what you're using in an environment, well, there's a whole different bunch of ways that you can choose what you're going to do and choose how dangerous it might be in different contexts. So you could look at how much energy it releases when it burns. Or you could look at the heat release rate. So you could have a material that releases a small amount of energy really quickly, or something that releases a large amount of energy but over a much longer period of time. And in different contexts, each could be dangerous. You could look at the ignition temperature. So when's it going to ignite? How easily is it going to ignite? A material which ignites really easily but releases a low amount of energy. Or you could have a material which is very difficult to ignite, but once it goes, it really goes, and it could then lead to onward ignition chains. And in different contexts, and in different products, and in different building sections, we use different measures. One of the measures that does tend to get used is surface flame spreads, particularly for materials on the outside of buildings. So it's sort of a combination of the two, how quickly something travels across the surface. We could look at its self-extinguishing ability. So when we apply a flame, it burns and adds to what we call the fire load, the amount of stuff burning. But then when you take the flame away, it actually puts itself out. It either forms some kind of char layer or it releases chemicals that disrupt the combustion mechanism, putting that fire out. So if the fire's removed, it's not dangerous. But if the fire's there, it's adding to that energy. So is it safe in that environment? Well, context specific. And even where you have materials that are non-combustible, you have to consider heat transfer. Recently, very recently, they discovered a series of cladding made entirely of aluminium, and it's failed the major test for cladding because it transfers heat so quickly through it that it can ignite all the materials behind if they're combustible in some way. So all of this stuff has to be considered when you're choosing materials to use. And this is controlled by a variety of British standards and mentioned a bit in the building guidelines, which I'll be coming across later. And they vary quite a lot between different countries as well. Countries don't agree on which standard are best. So there isn't one answer everywhere you look. The second way we try and control spread is when compartmentalization, a word I think that's been used a lot over the last 2 years and people have a better understanding. A compartment is basically a sealed box, or can be in the case of a fire, that should be fire safe for 30 or 60 minutes, depending on the rating, that keeps people in that environment safe. So that could be a room, it could be a corridor that people need to escape out of, it could be a stairwell. And the point of having those boxes is that, one, people need to be safe where they are if they're not near the fire. Two, if they are quite near the fire, they need boxes in which they can escape through safely. And three, the fire service need boxes that they can get up inside to get to the fire, ideally not using their air if they're having to use it. Now, we do that by looking at things like the structure. This is all related to materials as well, but we look at the walls, the doors, so we can use fire doors. For example, I've got an example of the side of some fire doors here. That white strip down the middle would represent something called an intumescent strip. And when exposed to fire, it swells, and it forms a nice seal around that will last for either 30 minutes or 60 minutes to stop smoke and heat getting in and keep people inside safe. You can use fire glass, which you'll all recognize, I think, from school or university. It's very common stuff. Spreads the energy through the glass so it doesn't smash. And again, that's rated for a certain time. The other thing you can do is this. It's called passive fire protection. One of the major problems with compartmentalization is that as soon as somebody drills a hole to put in some broadband or a new phone line or a new service of some kind, that compartmentalization's gone. You cannot guarantee that compartment for the time it's meant to be guaranteed for. And so you need to fill that gap properly to put that back. Otherwise, it's no longer a sealed compartment. It's no longer fire safe. And there are a whole bunch of different products you can use. This is a great picture from PBC that I love, showing a whole range of different things. And you can have fire-resistant mortars, insulation products. These are called fire pillows, the blue things, and they're filled with intumescent material as well. Swell up in the, when there's a fire next to them, they fill voids and stop heat and smoke from getting through. You have fire dampers inside ducts that stop fire finding a route through ducts. And fire collars are my favorite. They're rings of intumescent chemical around pipes. And if you look on the internet, actually, they're really cool. They crush the pipe and stop fire from being able to find a route through. So there are loads of ways to make sure that these compartments are sealed and safe. And again, that's mostly important to protect corridors, stairwells, and people in place. There are plenty of things that you have to consider with tall buildings, but I'll go through a couple of the others too. First is sprinklers, which are brilliant. And I will have to explain to you how they work, actually. I realize that wasn't in my talk originally, but bear with me. Sprinklers don't all go off at once. Could you all repeat that? Sprinklers don't all go off at once. We hate Hollywood. They keep showing this. Most sprinklers have a little glass bulb in the end with a fluid inside. It will boil at a certain temperature and break the glass. So only the sprinkler head, where it is hot, will burst. And that's the only place you'll get water coming down to control that fire. Okay? In England, new buildings over 30 meters have to have sprinklers in. In Scotland, new buildings over 18 meters have to have sprinklers in. So in this case, Scotland wins. They don't always. Sometimes England has better rules. In Wales, all new residential properties are going to have sprinklers, which is awesome, I think, for many reasons, which I will go through as we go through this talk. But it's really interesting, actually. BRE did a study on the cost-effectiveness of sprinklers. And that probably sounds a bit sort of hard-nosed, but when you're talking about putting in fire safety measures, there's always a cost. And there's a whole bunch of different measures you can put in. So you have to really kind of compare different ones to make sure, a bit like the NHS choosing where to spend their money to save the most lives. It's a similar kind of calculation sometimes that you've got to do. But yeah, BRE found that in buildings over 30 meters, sprinklers are definitely cost effective. In buildings over 18 meters, they're probably cost effective. So I don't know why we don't have that too, but anyway. And at some point also, you have to be thinking, well, shouldn't we be, as a society, spending money to save some lives too? It also saves property as well, so there are other benefits, hence the cost-effective one. They are effective at containing a fire in over 99% of cases. Most of the time, they'll put it out. And that, again, when you're talking about having this time to escape, time to be safe, time to get fire services in to fight the fire, that's a huge benefit. It means when the fire service get there, the fire's way smaller usually than it would have been. Way less resources having to be used, way less time to fight the fire. So I love sprinklers. Other things that are really useful in buildings, risers are fascinating. They're like tubes and valves that go at the outside of buildings, tall buildings. And they're effectively a way of getting water from the bottom to the top so that when the fire service go up there, they can use that water supply to fight the fire on that floor. They're amazing. Problem is, they are pipes that fill with water and they need quite a lot of maintenance because of that, and they don't necessarily get it. The final thing I want to talk about actually is the evacuation versus stay put policy, and it's very contentious for very good reason, particularly after Grenfell. The stay put policy is, to my understanding, stay put unless you are affected by the fire. So if you've got smoke coming in to a room that you're in, compartmentalization's breached, leave. If you are in some way affected by the fire, in my opinion, you shouldn't be being told to stay put anymore. There is a reason, well, several reasons why we have it. One, if you're in a safe compartment and you're going towards a fire, you're becoming more in danger, not less. You could be moving towards the fire if you don't know where it is. And you may well be safer in that compartment. Two, you could be stopping the fire service from getting in and fighting it and putting it out quicker. The third factor, which is a very serious one, is the possibility of panic and stampede. So every couple of years, there is a disco or a nightclub fire somewhere in the world. It's a really familiar pattern. There's usually some kind of flammable materials hanging from the ceiling or making up the ceiling. There's usually not enough fire escapes, or they haven't signposted them well, or maybe they've locked them because people have been coming in the back door. Sometimes they let too many people in a club because, what does it matter? A few more people and the license says, who cares? And in this scenario, sometimes a fire happens. Maybe it's somebody's discarded a cigarette and a bin's gone up. Maybe sometimes it's people on the stage lighting pyrotechnics inside that bands seem to like to do, except that there are internal suitable pyrotechnics, but they don't seem to get those. They seem to get the sort of outdoor ones that set fire to everything. The weirdest one by far was, I saw a video of a club in Essex that was ignited by a burlesque dancer who was using an angle grinder. And it's just sparks going everywhere. It's worth looking up. But in this scenario, what happens is that the stuff on the ceiling ignites and goes across and burns. Usually puts out the lighting, not enough emergency lighting. And at that point, when you have fire above your head, everyone panics. And they head for the one door they know about, which is the one they came in. And in those scenarios, there are always lots of deaths. And the people don't die from the fire or from the smoke, they die from the crush. And that's why some people don't want that mass evacuation scenario. But the problem is that the stay put policy relies on compartmentalization. And I told you, as soon as you drill a hole, it's gone. Well, now imagine that you've got a building that's 50 years old, and it's had multiple services put in and changed, and it may have walls changed, and people may have done DIY. The building owners may not actually have recorded things that have happened over the years. Maybe they only bought the building 3 years ago, and they have no idea what the fabric is like. So in that scenario, can you then guarantee that compartmentalization is still there and say that people are definitely safe in place? So when you hear people from the fire service at the Grenfell testimony, some of whom are saying, I think we should have looked earlier at stopping that stay put direction, and some of whom are saying, no, the stay-put policy was the right thing to do, it's because in this specific scenario, there's no easy answer. Either option could be dangerous for the people involved. And actually what we really need is a lot more information, a lot more research in this to make sure that, particularly with these older buildings, we can make them safe and work out the best way to handle these situations. And ideally, as far as the fire services are concerned, make them properly compartmentalised and make sure that happens. So I've alluded to some of this already. Well, what do they often not do? Well, sometimes it's incorrect materials. Sometimes the structure's made out of unfire-safe stuff. Fire doors is a real problem. Recently they did, I forget who it was, I think it might have been LBC, but it was with Arnold Tarling, the surveyor. And they went around Kensington and they took some fire doors out of the flats in the vicinity of Grenfell. And they did a fire test on it for doors that are meant to be rated to, I think, 30 minutes. And they lasted 15. How that happened, I don't know. I suspect it will be very much part of this inquiry. But that's a massive difference in time, especially if you're talking about a stairwell or a sealed corridor. That's a huge difference in terms of what you're doing. And the fire service based their actions on these ratings, assuming that people will be safe. Fire stopping is another issue. The building industry is very fond of expanding foam. You see it a lot. I see it at university, and every now and again I go to my health and safety people and I say, I've seen some expanding foam where I don't think there should be some. Could you please check it to make sure that it's okay in that scenario? The other issue around materials is that even if you're using everything that you're being told is safe to use, is the test actually representative? So the main test that you've seen on the news for cladding is BS 8414. It is a 10-meter tall wall where they ask people to come in and put in their insulation and cladding structure on it, and then they set fire to a wooden crib, a pile of wood at the bottom, and see how it behaves and see what temperatures are reached behind it. But there are two major problems with this test. One is the test is done inside a warehouse with no wind. Now, I don't know if you've ever stuck your arm out or stuck your head out of a tall building. It gets really breezy up there. And we're supposed to be using this test to tell us what's safe for buildings over 18 meters in height. So is that test actually representing the scenario it's supposed to be looking at, supposed to be testing for? One of the other major issues is something that was highlighted by the Fire Protection Association this year. And they changed out some of the wood for polymer. Not massive, a third, I think it was. And they looked at how that changed the test. And they found that the fire at the bottom burned much hotter and changed that scenario quite dramatically. Now, we all generally have lots of polymers in our homes. So again, is putting a wooden crib at the bottom of this test really representative of things we're supposed to be looking at? The other thing that is quite common is incorrect installation. Maybe you bought all the right fire doors, all the right fire kit, and what you actually have is then people trying to bodge it in, or people who don't quite know what they're doing. Here is a fire door picture I took. It's probably just legal-ish. It depends on the scenario. 4 millimeters is allowed in some cases. Any bigger than that, and you're talking about smoke and fire just going straight through. It's no use to anybody. Another issue, fire doors not shutting. That was never going to shut. I don't know whenever it did. This is particularly a problem in old buildings, but you'll see it in lots of places. This one always foxes people. You cannot quite see it. Maybe you can at the front. Can you see the top of the door? There are 2 holes at the very top of the door. And my students, when I was teaching fire safety assessment, always missed this one as well. Those holes are there because there was a door closer on that door, heavy thing to make sure the door closes and seals that compartment. It's gone. I don't know why it's gone. Did it break? Did somebody nick it because it was made of metal and they wanted to flog it? Not a clue. But that's no longer a fire-safe door. That's no longer a fire-safe compartment. Completely changes that environment. So in terms of fire stopping, So again, people are very fond of expanding foam. There are currently no government recommended qualifications for doing this sort of work, even though it saves lives. Nothing centrally that anybody recommends to say, this is how you do fire stopping, this is who you should be hiring to do it. So I do sympathize, actually, with building owners, people who run buildings, because I've actually spoken to building managers, and they've come up to me and gone, how do I know? I mean, I've just sat through your lecture, and you've told me there's all this stuff that's really complicated, and I have no idea who I'm supposed to be asking or who I'm supposed to be employing. So we need that as a start. We need a guide of some sort. There is, by the way, if you're looking for fire safety assessors, so people who go around buildings to actually assess how safe it is, the Institute of Fire Engineers have a list of people they recognise as being qualified. So if you are looking for a fire safety assessor, please do look. But at the moment, by law, anybody can do a fire safety assessment. In fact, the government have reams of guides on their website showing you how to do it. A guide for doing it in schools, a guide for doing it in hospitals. I'm a fire scientist, and I shouldn't be doing this in a school. But somehow we don't require qualifications. And I said the bigger the building gets, the more complicated this stuff gets. Oh, this is my favorite. The other thing that buildings don't handle very well is change. You might build the most wonderful, perfect fire safety, brilliant building in the world, and then somebody comes along and does this. Can you see this? I'm not sure if you can, given the light. There is a hole in that fire door. Somebody put in a stair lift or something similar in a hotel, and it didn't quite fit. So they just chopped a chunk out of the fire door. And then they left the sticker on. I don't think that's fire safe. So change is a real problem. And one of the biggest issues is that fire safety is an afterthought. And part of that is that none of us are taught it. Not really, not how to understand why we have to do all those things that the fire safety people at work make us do. We're never really told about why it's so important and the terrible things that can happen otherwise. It's an afterthought in the building industry. They kind of think build thing first, then make fire safe, rather than make it inherently part of the process sometimes. Not always. There are always going to be good and bad examples of this. Elephant in the room. I couldn't talk here without discussing cladding. I mentioned materials earlier, and this is obviously key importance. This is a cladding system. You have your inside of your building, you have a wall or some sort of structure. On the outside of that is the insulation. You have a void, or as we like to call it in the fire industry, a chimney. And then you have a cladding system on the outside that can be made of a variety of things. Could be metal and polymer, could be ceramic. My work has a ceramic system, has its own problems. You could just have metal system. Now, the reason they do it this way is because it's the easiest way to green a building. If you want to make it energy efficient, you stick your insulation on the outside, and if you put your insulation on the outside, it needs weather protection, and that's what the cladding is there for. It's not prettifying. It's there to protect the insulation that you've put on it. So, following Grenfell, following those pictures of that mass fire spread up the outside of the building extremely quickly, way quicker than anybody thought it should be possible, BRE did testing on 7 different combinations of polymer aluminium cladding and internal insulation. As we've got polyethylene, fire-retarded polyethylene, material of limited combustibility, polyisocyanurate, stone wool, which is non-combustible, and a phenolic, another polymer. And they found that 7 of the commonly used cladding systems that they tested failed the test for safety and shouldn't be anywhere near these tall buildings. And that's why you're hearing about hundreds of buildings thus far. I mean, my last count that I saw was 390, I think, in the press. But it's likely to be more because there's plenty of people who haven't identified this. That's why hundreds of these are now, well, having to be taken down, being argued over being taken down. But there is also this asterisk here that was put on the test by BRE, and that was that the pass of this test depended entirely on how these materials were installed. If you got the installation a bit wrong, they couldn't guarantee a pass anymore. So how did we get here? Well, firstly, ignoring some of the warnings of the past. In 2005, they changed the system in England and Wales. Sorry, it will be a bit England-focused today, because that's where we happened. They changed the system so that before, we used to have buildings certified by as safe by a fire service. And then they changed it so that actually they said, no, the local authority or building inspectors will handle the safe building bit, and the fire service will just look at the next bit, the safe use of the building, and check it, because we'll define these wonderful guidelines that will make sure that people know what a safe building looks like. And at the time, fire service said, this doesn't sound like a good idea. We don't think it is. We think it will result in problems. In terms of cladding, I've been hearing people with real concerns for a good 10 to 15 years talk about they were seeing fire spread, they were seeing things that they were told weren't possible, and yet on the ground, anecdotally, but still, they were seeing things that they were being told shouldn't be possible in terms of fire spread, and they were very concerned. And those weren't entirely listened to. And if you look on the internet, there's loads of examples of these fires in Dubai. There's a big one in France, one in Melbourne. That should have been an indication. But for me, the biggest failure is Lakanal House. Lakanal House was a very bad fire that happened in 2009. Happened during the day, 14-story building, it's about 40 meters. They needed 18 fire engines to come and, fire appliances to come and fight the fire. So it was a really serious fire. It resulted in 6 deaths and at least 20 injuries. And the coroner's report was the main sort of outcome of this. That wasn't for 4 years later. It's an excellent report. It was scathing. It pointed out that Southwark didn't do any fire safety checks for 3 years. The fire service didn't have a map of the flat, so they actually didn't check everything. So at one point, somebody in the flat was being told to stay put because the fire service were coming to her, and that was not true. And so she died in that position. They replaced some of the window panels, sort of cladding, if you like, but it's not. It used to be asbestos, which is very fireproof, but of course also very dangerous. And they replaced it for composite material, which burned through in about 4.5 minutes. So a completely different scenario. And again, not something that anybody was expecting. Following that coroner's report, 4 years later, the government then instigated a review that was going to report 2016, 2017. It got delayed, it got pushed back. But still, that was going to be like 8 years after this had happened. That's too slow when you've had deaths in an environment you shouldn't have had deaths in. The other issue is that, across the country, how we design and run buildings is a bit of a mess. Technically, you'd say there are multiple routes to compliance for all sorts of things, but it's really ruddy complicated. England and Wales, we have this approved document B, which is attached to the building regulations. Everybody refers to them as the regulations, except they are guidelines, not regulations. And you can actually do anything you like as long as you can convince the building inspector that it's fire safe. Volume 1 deals with dwelling houses, and it says, the only sentence on tall buildings, where very large, over 18 meters in height or unusual dwelling houses are proposed, some of the guidance in Volume 2 may be needed to supplement that given in Volume 1. Maybe. But they have to put it that way because actually you don't have to use the guidelines at all. You could do anything. Now, Volume 2 has a lot of information on a lot of safety features, stairwells, corridors, firefighting equipment, all kinds of things. But again, that all depends on how everything's defined, what British standards you're using, whether you're using the right measures. And it's very complicated. Building use, that's covered by the Regulatory Reform Fire Order of 2005, and that's the bit that the fire service get to do. So you've got the first bit handled by private building inspectors, or local authorities, either one, 2 different options. And you've got the next bit that if it's a workplace, HSE will get involved, or the UK Health and Safety Executive, or the fire service, or both. And that system looks like this. It's really complicated. There are multiple routes all over. I think this is sort of a materials thing, but the main system for actually building, getting certified a building and running it is up here. And there are three major issues with this. Right. One, you've got that big break at the top, like I said. First section is done by local authorities or building inspectors, second section by fire service, as though those two aren't connected. Now, I've just done some research and writing a paper at the moment. I sent 53 Freedom of Information requests, because in the first stage, the local authorities are meant to consult by law with the fire service to ask them what they think about the building. This results in a lot of work for the fire service, but they review it and they send it back. Now, in some cases, what did I do? I looked at West Midlands, Manchester, and London. In some cases, the councils did everything the fire service told them to. They said, yep, these are all the things. They said, here, builder, you have to do that. In some cases, they got the information from the fire service and they said, well, okay, we'll do this bit here, but the way the building guidelines are written, we don't think that we can tell people to do this bit. So you have a scenario where the fire safety experts are actively being ignored because the council don't think they can do it. There were a couple of councils who received the consultation information, didn't even look at it, threw it on to the builder and said, there we go, job done. We don't have to know what's in that. The building inspector route isn't any better. That's the sort of bit at the top. Private in building, you can hire a private building inspector to assess your building, but of course that means you're paying the person who's assessing you. And that's what we like to call regulatory capture. If someone's sort of repeat business depends on, or if they benefit from some way from that scenario, it's not a healthy system to have. The other issue, which I've alluded to already, there is no mention of qualifications in this whatsoever. This is the system by which we govern how fire safe a building is, and it doesn't mention fire engineering once. Not at all. It doesn't mention any qualifications of any kind. There are multiple approaches to getting cladding on. You could use BS 8414, you could use BS 476, you could have a classification that is either a UK classification or a Euro classification. Multiple different ways to get it on. Worse, you could have somebody do something called a desktop study. Again, actually no qualifications technically required, where they say, okay, I want to use this material, and they look at it and go, yeah, that's like that material. Yeah, use it, it's fine. No testing has to be done. Just sign on a piece of paper, done our desktop study, and that was allowed by some of the building inspection regimes. I don't normally do massive slides of text, but I really think it's worth visiting. That big structure that I showed earlier was from Judith Hackett's report for the Independent Review of Building Guidelines done for the government last year. And it's a really good piece of work in defining what's wrong with the current system. She looked at how we build buildings, how we maintain buildings, and she found all of these issues. The current system is not fit for purpose, she said, for maintaining fire safety in tall buildings. I mean, after everything I told you, hopefully, I think you might agree that actually the current system is not fit for purpose at all. Regulation guidance and definitions are complex and unclear. Roles and responsibilities aren't defined. Culture of minimum compliance in the building industry, not lifetime safety. Inadequate definitions of competence. Widespread deviation from what they told us they were going to build and then what they built. And nobody doing anything about it. No requirement to bring old buildings up to spec. And this is one of the biggest issues. We don't backdate any of our fire regs in terms of building safety. So new buildings have to have the sprinklers, but old ones don't. And this is bizarre. Also, if you're renovating a building, only the bits that you're renovating do you have to build up to modern levels of safety. Otherwise, you can leave it as it is. And it's a bit like having a jigsaw puzzle. I've said fire safety is a complex mix of different things. And if you've got bits of that jigsaw missing, then you haven't got an entirely fire-safe picture. There are lots of barriers to enforcement. such as fire service advice being ignored, cost of courts, lack of sanctions, no requirement for fire risk assessments. And actually that two-stage system that I said about, one of the biggest issues with it is that where before you had to prove to the fire service before 2005 that your building was safe, now the fire service has to prove it is unsafe. So it's quite a different thing when you're talking about actually having to take it through courts and prove stuff. Variable information complaints procedures for residents. This was one of the biggest complaints from Grenfell residents. They complained, nothing happened. And in fact, actually, I'll deal with that in a second, but yeah, so testing and certification, I've said, can be unrepresentative. So what do we do going forwards? Basically, we have to completely think how we build, use, and redevelop buildings. Completely change that system. Something that's been visited on a little bit, but hasn't entirely been mentioned, is the siting of vulnerable individuals. And we are going to have, in houses of multiple occupation, lots and lots of dwellings in one building, lots of vulnerable individuals, elderly people, children, people with limited mobility. And I'm not sure we really address that properly at the moment in terms of fire safety plans for houses and for homes. The latest London Mayor's plan for new builds in London has actually said that they would like every new building in London with homes in to have fire lifts to make sure that everybody can get out no matter what their mobility issues, which I think is really positive. But at the moment, we don't have that. I don't think it's being addressed particularly well. We really need to examine the relationship between evacuation, stay put, compartmentalisation, and sprinklers, and try and get a lot more information on what's going on out there. I'd like to look at green and sustainable buildings. There are lots of pots of money for putting insulation on the outside of buildings, which is lovely, but they never mention fire safety in any of them that I've seen. And as far as I'm concerned, a building that is easier to burn down isn't as sustainable. We need to review all the qualifications that I've said about. And we need a system where residents can actually get the information on their own environment where they live to know how safe it is and challenge that. Well, you'll be pleased to know some things are already happening. Obviously, there are 2 inquiries that are ongoing. We'll find out more about that. But there is information and action happening already. One of the most interesting reports I read after Grenfell was the Mind the Gap report, which came from a series of charities who worked in Kensington in the immediate aftermath of Grenfell. And it's a really honest and well-written report, I think, saying what they did that worked, what they did that didn't work, the help they got from the authorities, and the help that they wished they desperately needed that they never had. And I hope that it will form the basis of really sorting out how local authorities and charities work together when there are disasters in the future, because there probably will be, unfortunately, and we need to be ready for those. There is a £400 million fund the government have released for replacing cladding on social and residential housing. Only the social, not private. And there are lots of arguments over who is liable for those costs or who should be. I honestly would like to see, if nothing else, a loan system that the government would loan people the money to get the unsafe stuff off the buildings, and then they can argue about the legality after the inquiry's reported, because I think it would be a better thing to do that way around. One of the best things to come out over the last year is the Fire Safety Information Bill. Maria Miller, the Conservative MP, has used her private member's bill to put this in, and it's cross-party supported, and it will result in people who run buildings or own buildings, they have to sit down every year and tell people the fire safety assessment and tell people the fire safety plan. And so people will have an open forum where they can discuss that and challenge it. And it will end what until now has been really quite a secretive process. I know somebody who only got the fire safety assessment on the building he lived in by putting in a freedom of information request to his local council who happened to own the building. He couldn't get it otherwise. They wouldn't just give it to him, even though it was a local authority. Last week, the government announced a ban on combustible materials on the outside of tall buildings. New ones. There are no details yet, there is no timeline, and I would urge you to poke your MPs and try and get them to move on that, because the sooner we can get some information on this, the better. In terms of sprinklers, I think people are watching Wales very carefully now that they've put this new law in to have all residential properties have sprinklers in. I wish that they would do it everywhere, because again, with vulnerable individuals in these environments, that's really important. And we have a relatively accessible world now. So there are going to be people with mobility issues everywhere, and they should be safe. That said, there are a number of councils and towns all around the country who have now said they're going to put in sprinklers in tall buildings, which I think is a really positive step. The final thing I want to talk about here is the Hackett Review. The final recommendations were pretty much the conclusion I had in the last slide, which is rip it down and build it up again, proposing a whole new system of how we build and maintain buildings, particularly with oversight from beginning to end by one entity. This is what her new system looks like. Much simpler than the old one, much easier to understand so that everybody knows what they're meant to be doing. And this entity across the top, which involves local authorities, health and safety executive, and the fire service, whichever one happens to be in that environment, from beginning to end, so that there's always fire safety in that process. Again, I haven't seen any timescales on this or actual acceptance of it by the government in any real rapid way, so I hope that you will encourage your local authorities or MPs to push this through. So to summarise, fire safety in tall buildings is simple in some ways, but really complicated in others. The regulation we have isn't fit for purpose, and the warnings have been there, but haven't necessarily been heeded perhaps as quickly as they should have been. Progress is being made, but is it enough? Well, I'm not sure, honestly. We're only at the start of this journey, but there is enough expertise in this country, and certainly enough will amongst all of the industries I've spoken to, including engineering, architects, builders, fire industry. We all want to make this work. So I would hope that you go away and look at the fire safety in your environment and appreciate what's being done around you, maybe assess what's not being done that you think should be, and question the authorities on this and see that they're really helping to change things that need changing. Thank you.
Thank you so much, Claire Benson.